Does the sky look different lately? Fewer stars, more emptiness, like the universe is just ghosting us? You're not imagining it. Yes, the sky really does have fewer stars today. And no, it's not just light pollution, smog, or your awful phone camera. Something much, much weirder is going on. To explain it, we need to zoom out and zoom into our oven. Imagine a tiny ant standing on a giant loaf of raisin bread. As the bread bakes, it rises. The raisins, aka galaxies, drift farther apart. But not because the raisins are moving. The bread itself is expanding. And it's rising faster and faster. That's our universe. You're the ant. Bread is space. Raisins are galaxies. More space is being added between galaxies, like someone's inflating the dough of the cosmos. But how do we know the bread is rising? It's not as simple as just looking through the oven glass. We know that light from distant stars is like looking into the past, old light, carrying ancient stories about the universe. This helps scientists figure out the speed of stars across time, and tells us if they're moving away from us faster or slower. Another clue? Redshift. When galaxies move away from us, their light shifts red, like a cosmic left the chat notification. The redder the light, the faster they're moving away. Simple enough, right? Almost. What happens when there's a dim star nearby and a brighter one farther away? How do we know which is which? That's where astronomers look for standard candles. Special stars, type 1a supernovae, that always explode with the same brightness, like cosmic light bulbs. Hence, if one looks dimmer than expected, it's farther away. Boom, distance measured. So, scientists started observing these candles, expecting to find the universe slowing down a bit, since gravity should be pulling everything inward. But nope, the opposite happened. The stars were drifting away faster than ever. Some scientists started wondering, if the universe is expanding now, maybe it was once a lot smaller, like infinitely smaller. So they proposed a theory that the universe began as a hot, extremely dense, tiny dot. People laughed. They sarcastically called the idea the Big Bang. The joke? Totally backfired. Turns out, the universe really did start with a bang, and it's been stretching ever since. But where's gravity in all this? Well, gravity's the responsible one. It's been trying to stop the expansion, pulling on everything like a cosmic bungee cord. Some thought the universe might eventually slow down and collapse in a big crunch, a dramatic cosmic rewind. But there's another player in this tug of war. Space, the dough itself, isn't just an empty void. It's a physical thing that can bend, ripple, and expand, and something out there is stretching it faster than ever. Some mysterious force is creating more and more space. And since we know almost nothing about it, we've given it a mysterious name, dark energy. It makes up about 2/3 of the universe's energy budget, roughly 68% of the entire universe. But if we can't see it or touch it, how are we measuring all these invisible components of the universe? Drumroll, please. It all started with a photo. Not of today's universe, but of the baby universe. It's called the Cosmic Microwave Background, CMB, a snapshot of the universe just 380,000 years after the Big Bang. It captures the first photons released after the formation of the early universe. Not this picture, this is just my sourdough bread under a microscope. But it's somewhat the same. I mean, doesn't everything look mysterious and same under a microscope? But you get the idea. To see the real image, check out the book We Have No Idea by George Cham and Daniel Whiteson. So scientists took this photo of the early universe and ran simulations forward and backward in time. The number of wrinkles and patterns in the image revealed the specific proportions of dark matter, dark energy, and normal matter in the universe, which is 5% of the universe is normal stuff. You, me, snacks. 27% is dark matter, and 68% is dark energy. If those numbers were different, the baby photo would have looked different too. So yeah, we know dark energy exists. We know how much of it there is, but we have no idea what it actually is. There are some theories. One says it's the vacuum energy of empty space. Even nothingness isn't really nothing. Thanks to quantum physics, it's full of energy fluctuations. At quantum levels, particles pop into and out of existence, like bubbles in boiling water. So maybe empty space has its own gravitational effect, pushing everything outward. Cool idea, until scientists tried calculating it. The result? They were off by a number with 120 zeros. So yeah, not exactly a precision guess. There are other theories too, but they're hard to test. So we're back to square one. We know dark energy is real, we know it's huge, and we have no idea what it is. Here's the wild part. If the universe keeps expanding like this, galaxies will eventually drift too far to see. Literally, light won't reach us anymore. And already there are fewer stars visible today than in the past. In billions of years, future humans, or aliens, might look up and see nothing. No galaxies, no stars, just cold, quiet, black.
Thanks for watching. If you enjoyed this video, you'll probably love our last one on dark matter too. Don't miss the next episode, and remember, a big read leads to big ideas.